Hello, in the prior section, we concerned ourselves with a lot of vocabulary that had to do with straight line segments. Today we're going to be focusing a lot on angles. And so we got to start with our vocabulary, because as I said, geometry is very vocabulary based. So some vocabulary for angles. The first one is a ray. A ray is part of a line that has one end point and the other end extending outward to infinity. So M is the end point. It goes through point P and it extends to infinity. If you have a ray, uh, you denote it by the two letters, and then you draw a line over it with an arrow on the one side that it extends towards infinity. You can think of it like a sun ray. Sun ray starts at the sun and goes onward towards infinity. An angle is made by two non-collinear rays. They can't be in the same line is all that means. We call those sides of the angle, and then they share a common endpoint that we call the vertex. So for example, this angle, angle ZXY, is formed by ray XY and ray XZ meeting at point X. There's a few ways that we can name an angle. Do we talk about that in the next part? Yeah, we do. Okay, so I guess we'll get to that. But there's an example of an angle. Now we're going to talk about how you name an angle. It turns out there are three ways that you name an angle. You can name it by its vertex, as long as that vertex is not part of another angle in the figure. You can name it by a number, and you can name it by the 3 points that make up the angle. So name all the angles for the red angle shown. So list all the ways you could name this angle. Well, the first one we said is you can name it by its vertex. So that would be angle B, and we use this little angle symbol. It looks like an angle itself. So you could say angle B. We said you can name it by the number, so angle 1. Or you can name it by the 3 points, angle A, B, C. You could also call it angle CBA. What you could not name it though is angle CAB, because A is not the vertex. The vertex has to be the middle one. So B has to be in the middle of this naming because B is the vertex. So those are all three different ways. The last two are pretty much the same that you could name that angle. Now I've got a question though. What if it looked like this? Which name is no longer appropriate? Well, naming this angle B is no longer appropriate because if I named it angle B, so angle B is no longer appropriate because it's not clear which one we're talking about. Are we talking about angle B in reference to angle 1, or are we talking about angle B in reference to angle 2? So that's where I said you can name it by its vertex as long as that vertex is not part of another angle in the same figure. So this would be an example of where you should only use angle 1, angle 2, or the letters. When you measure an angle, the tool that we use is a protractor. A protractor measures angles in what we call degrees. Degrees are the units that we measure an angle. 1 degree is 1/360th the way around a circle. It kind of relates to the days in a year. It has to deal with prior civilizations that measured in different bases, a base of 60. 60 times 60 would make 360, and it had a nice divisibility with lunar cycles and our yearly cycle, so that's where it's believed it most likely comes from. The protractor, when you are measuring an angle, you have to place the vertex at its center. You need to align the bottom ray along so that would be at the 0 degree, and then you measure the other angle by reading the protractor. And so since ED is aligned with 0, we can read ray EF and see that this is measuring angle 50. This bottom scale is used to measure it opening, the best way to describe that, maybe counterclockwise. If you had an angle that was opening clockwise, you would use the top scale. So it just depends on which direction the angle is opening. Based on the measurement of that angle, we have different ways to classify it. If the measurement of the angle is a 90-degree angle, we call that a right angle. I know you've known that. If it's less than 90 degrees, we call it acute. And if the angle measures more than 90 degrees but still less than 180, we call it obtuse. So right acute is less than 90, obtuse is more than 90 but still less than 180. I'm going to give you just a quick chance to try. Can you tell me what the following angles would be? Are they going to be acute, right, or obtuse? So angle MJP, LJP, and NJP. If you need to, pause the video right now and then unpause it once you've had a chance to try. Okay, first one. Welcome back. MJP is this angle right here. That makes a 90-degree angle, so that would be a right angle. Next one is LJP. LJP. That opens more than 90 degrees but less than 180. That would be obtuse. Angle NJP. So start at N, go to J, and then P. That is less than 90. That would be an acute angle. When you start to measure angles, you can do things like last section, we looked at the middle of a line segment. We can kind of do that for angles. We call it the angle bisector, where it splits the angle into two equal pieces, because the midpoint kind of split the line into two equal parts. The angle bisector is a ray that divides an angle into two congruent meaning equal measurement angles. So this original angle measured 160 degrees, but then ray YW cut it into two equal pieces. And because it cut it into two equal pieces, it is called an angle bisector. If it cut it into two unequal pieces, it would not be an angle bisector. If it had cut that 160 degrees so that one of them was measurement of 110 and the other was 150, that would no longer be a bisector because it doesn't divide it into two equal pieces. It needs to divide it into two equal pieces. Here's a type of problem that you could solve based on the definition of angle bisector. So you need to read the directions carefully and use each clue. This is a lot like solving a puzzle. So it says KN bisects JKL. So JKL gets cut in half by KN. Here's how we actually denote that. So if you wanted to, you can put little arcs in here. And because these arcs have the same, you can either would say they both have one, or you'll see little dashes. Since these both have one dash, we're marking that they are the same. If they were unequal, maybe one of them would have one dash, one of them would have two. That would say that they are unequal. But right now, since they both have one dash, that's showing that they are congruent. We know that measurement of angle JKN is 8x minus 13. So here, this is 8x minus 13. And then we also know that NKL is 6x plus 11. Now it asks us to find the measurement of JKN. Well, in order to find JKN, I need to know what x is. How am I going to figure out what x is? I need to use that first clue. It told me that KN bisected the entire big angle. That means the green measurement and the blue measurement are the exact same. I know 8x minus 13 is equal to 6x plus 11. Now I'm just solving an algebra equation. Get my variables to one side, numbers to one side. Add 13, subtract 6x, divide by 2, and I get x equals 12. But that doesn't answer the question. The question asked me, what is the measurement of JKN? That is this blue angle. You could also find the green one because they're equal, but if it's specifically asking me for JKN, the measure of angle, so M just means measurement, angle symbol, JKN is equal to 8x minus 13, but now I know that x is 12, so I can run it. 8 times 12 minus 13 tells me that JKN, oh, I did it right here, is 83 degrees. If JKN is 83 degrees, then you know that NKL is also 83 degrees. And if it asked you for the whole entire, you would do 83 plus 83. But it didn't. It just asked me for JKN. The ACT and the SAT love to do questions like this, where you need to put multiple parts together and make sure you answered the original final question. The final question was, what's the measure of JKN? So you're not done at x equals 12. You need to use that to get your final answer. Other vocabulary, so angles can also come in specific pairs. If they are next to one another, we call them adjacent angles. So two angles that share a common side and a vertex. Angles 1 and 2 here are adjacent. Angles 1 and 2 here are adjacent. An example of a non-adjacent pair would be if I had something like this. If this was angle 1, and then over here this was like angle 2. Those would no longer be adjacent because they do not share a common vertex. So those are not adjacent. A linear pair. A linear pair are adjacent angles whose angles add up to 180 degrees. So 1 and 2, they are on a straight line, and straight lines add up to 180 degrees. So 1 and 2 are what we call a linear pair. They add up to be 180. An example of a non-linear pair would be like angles B and D here. Those would not add up to be 180 degrees. Vertical angles are angles that are directly across from one another, formed by two intersecting lines. They are actually congruent. So here's two intersecting lines. The angles that are across from one another are called vertical angles. So 1 and 2 are vertical, they would be equal to one another. 3 and 4 are vertical, they would be equal to one another. Examples would be like angle 1 and angle 2 here. Those are not going to be vertical angles because they do not occur across from one another by two intersecting lines. There's actually 1, 2, 3 lines coming in here. Let's use some colors. You've got this red line, you've got this blue line, and you've got this angled purple line. Those are 3 lines intersecting, so that's not going to be vertical angles. So that would not be vertical angles. Complementary angles are two angles that add up to be 90 degrees. Supplementary are two angles who add up to be 180 degrees. To kind of help you remember this, I like to think alphabetical and numerical order. C comes before S and 90 comes before 180 in terms of counting up. So complementary associates with 90 degrees, supplementary associates 180 degrees. Unfortunately, both complement and supplement come from Latin words for complete and supply that are in reference to completing 90 degrees or completing 180 degrees or supplying 180 degrees. So there's no good way to remember using root words in this case because they both kind of have a similar root word. Type of example of a question that you could be asked to solve that deals with complementary or supplementary looks like this. It says two supplementary angles. Let's just pause right there. Two supplementary angles. If they are supplementary, S comes after C, so that means that they add up to be 180 degrees. So that clue tells me X plus Y equals 180 degrees. Now it says they have a difference of 36 degrees. That means if I subtract them, they'll equal 36 degrees. What is the measurement of each? This is actually a system of equations. We solved this back, in a prior semester. If you notice, the y's will cancel out if I add the two equations. We could use what we call the elimination here. Add the equations, I get 2x. The y's will cancel out. 180 plus 36 is 216. Divide by 2, and I get 108. So one of the angles is 108 degrees. That's x. How do I find the measurement of angle y? Well, y is equal to 180 minus 108. If I subtract, I will get 72 degrees. So x is 108 degrees, y is 72 degrees. They add up to be 180. If I subtract them, they'll be 36 degrees. Perpendicular lines are lines they're going to just cross and form 4 right angles. So they cross at 4 90-degree angles. This would be line AD and line BC. We write it using this notation. AD, and then the perpendicular symbol is like an upside down T, showing that they cross at 90-degree angles. We'd say AD is perpendicular to CB. The following properties can be read right here, but the biggest part is it makes 90-degree angles. Be aware though, just because a figure looks like they cross at 90-degree angles, unless one of those angles is marked as 90, you cannot assume that they are perpendicular. So you can just not go assuming things just because it kind of looks like it. Here's a list that the book supplies of things that are fair to assume for the following figure and things that are not fair to assume based on the following figure. It might be wise if you read through these, read which ones are fair to assume and which ones are not fair to assume. Essentially, unless it's marked, you probably cannot assume things like congruent or perpendicular. You can assume things like points that appear on a line, or angles that appear to make an angle, but you can't assume much more than that besides the fact that they're there. Here's an example of a problem, then I'll have you try one and that'll be it. So this says, find x so that PR and SQ are perpendicular. Well, PR, let's do that in green. So here's PR and SQ are perpendicular. If we know that these are going to be perpendicular, we know that these are going to make a 90-degree angle. So that means this is 90 degrees, that's 90, that's 90, that's 90. Well, it says find x so that those would cross at a 90-degree angle. Well, look, 90 degrees is the sum of those two angles. Those two angles are complementary because they add up to be 90 degrees. So I know 2x plus 5x plus 6 has to equal 90. Solve. 7x equals 84. Divide by 7, and you get that x is 12 degrees. Now, so I found x. I'd like you to figure out what y would be. Find the measurement of y if P, R, and SQ again are perpendicular. Pause the video, unpause it after maybe a minute, and you've had a chance to try. Okay, this is almost identical to the one we just did. I know if these are going to be crossing perpendicular, then this has to make a 90-degree angle. So I know 4y minus 2 has to equal 90, add 2, divide by 4, and I get that y has to be a measurement of 23 degrees. So there we go. Thank you very much. Have a good one.